This is second part of chapter 5. We were looking at this query in the uh, slides, and here I run it. So let us understand what this empty parenthesis is for. Look at the last line. Okay, sorry. All right, look at this last line. Basically, it shows up by all the columns that we have over here: vendor state, vendor city, vendor zip code, all the columns that we used in group by. So empty parenthesis basically tells it to roll up by all of them, and if I delete that, we lost the last line of it, and we are no longer rolling up by all the columns. So that gives you like a more advanced control over rolling up the columns. Okay, let's go back to the queries. We need to talk about the overclose. This is something that is used often in data science, in aggregating data for data pipelines. So basically, we don't just sum over invoice total, but we do it over a partition by invoice date. So our table is partitioned by the date, and the sum is taken by every day. So by every date available in the table, more precisely. Same with the invoice total. The sum is taken by date, every date that is in the table, and average as well. And we can see the results. So on some days there are 3 invoices on, and this is the total. And actually there is 3 different rows for the same with the same aggregate data and with the original data in invoice total. So in one table, we're able to include invoice total and also the aggregates that we wanted. Okay, and another way to aggregate is moving average. So moving average is, in this case, taking the first data points and, for example, averaging them and computing the accumulated total. So we had this data. The first 3 columns are from our original data set, from the original table. And over here, we are gradually accumulating. So the first was the earliest with $3,813 and change, and this is our cumulative total. And the count is 1. The next time, in a couple of days, there is an invoice for $40. It is accumulated and counted, and now we average these 2 previous invoices to get this number. And let us jump to row 6. This is the new invoice total. It is adjusting the, actually they are on the same date. These 3 are on the same date, so they are all already accounted in cumulative total. That's why the value is the same and the count is the same. But all of these 3 are affecting the moving average. The moving average is now average between these 6 numbers. So that's how the moving average works. So you choose a cutoff date and you count all the average of everything on that date and before that date. There are various variations about that. If you have seen, for example, stocks trading, there's various moving averages that are used. And in general, it is a very important smoothing operation that allows you to see the data better, to see the trend better, I should say. And we are doing very little with it in this chapter, and I think we're done. Oh, one more. So a little bit more sophisticated partition with order by. So we are doing partition by terms ID. Here is our terms ID. The beginning 3, 4 rows are actually, the beginning 4 columns are actually from original data. And we are computing cumulative total, counts, and moving averages for each term ID and by invoice date. So within each term's ID, we are ordering all the relevant rows of our original table, and we are computing cumulative total, and we are computing a count. Notice that we see the middle of the table, the snippet of the table, and so there are already some accumulated number of invoices. And on this day, there was invoice for $356. It is accounted in the new total, and the count changes by 1. Here, another total for 579, count changed by 1, the total changed accordingly, and moving average changed as well. And that's it. So there is a wonderful world out there of various characteristics of data, such as beginning with moving average and variations of moving average. And we have seen a couple of examples of that, but that's about it for this week.